This is the Avengers Endgame Timeline explained with science. Even if you're not a Marvel nerd, it's hard to argue that the Marvel Cinematic Universe isn't incredibly impressive as a venture in storytelling, in business, and in pop culture. Over 10 years, billions and billions of dollars, 22 films, some of which are the most successful of all time. And now with Endgame, this era of the MCU closes with the culmination of a truly epic arc. But because Marvel has decided to be so delightfully sciencey in many of its movies, is there a way for us to more realistically interpret what actually happened in Endgame? Let's figure it out. I guess we're in the Endgame now. Before we get started, we are going to be literally spoiling the entirety of Avengers Endgame. So if you have not seen the movie yet, you absolutely have to turn back right now. Alright, so by the end of Infinity War, Thanos has won, dusting half of the universe in the process. To reverse this terrible deed and to avenge all of those who fell, the remaining Avengers have a plan. Jump into the quantum realm multiple times in order to time travel, steal the Infinity Stones in the past, and undo the snap in the present. It's a mind-bending and satisfying end to a decade-long story. Time travel is inherently confusing, so how exactly did the Avengers accomplish this? What did their path through space-time actually look like? I escaped the void for a brief and beautiful moment of time just to attend the world premiere somehow of Avengers Endgame with a notepad in order to take down notes in the dark to get out a video just in time for all of you nerds, and this is what I came up with. These are the events of Avengers Endgame laid out chronologically with all the weird time travel-y stuff going on. This is what we have to science. Is any of this plausible with the laws of physics as we know them? Is Professor Hulk better than the regular Hulk? We'll come back to this in a bit. But not the Professor Hulk thing, he's much better. First, let's do our best to wrap our heads around what time travel actually is. From a scientific perspective, traveling to different points in time is like traveling to different points in space. Like I just did. If this is a graph of my position, I went from here to here. Now let's add time to the mix. When I took that step, it had to have occurred over some time. And when I trace that path, you can see that I am taking a path through both time and space. But because we are talking about space-time, we also need some kind of boundary here that would prevent us from going faster and further than light could in the same space-time. This is our light speed boundary. Now, if we add the rest of three-dimensional space, x, y, and z, except we are suppressing z here because we cannot see in 4 dimensions, we can trace every single point in space and time that you could possibly take. And this is what physicists call your world line. Finally, if we rotate our light speed boundary across all of the other dimensions, we get what looks like a cone, what scientists call your light cone. So now we have a world line, which is your entire life history at every point in space and every point in time, and then your light cone, which defines every single point in space-time where you could go or have been. And light cones are what we are going to mess with to travel through time. Oh, hey! The easiest way to travel through time is to go forwards in time. You and I are traveling forwards into the future right now at the blistering pace of 1 second every second. If you want to travel into the future faster than this, you either have to go really, really, really fast, or you have to get near something really heavy. Wow, it's good to have that back. Let's draw our diagram again, and this time assume that we have 2 individuals, one going really, really fast and one just standing still as space-time progresses. It's nice to have you back too, buddy. Now, the really, really weird thing is that even though this looks like more time is passing for the person who is going super, super fast, when you go that fast, space-time squishes. Once space-time has squished due to her immense speed, you can see that the time that has passed for Captain Marvel from Spider-Man's perspective is actually less than the amount of time that has passed for Spider-Man. This is forwards time travel because from Carol's perspective, she has aged less than the rest of the universe. Now, we've never gone Captain Marvel fast to make significant forward time travel a thing, but we have gone fast enough to see forward time travel effects. Over his over 800 days in space, orbiting the Earth at many kilometers per second, cosmonaut Sergei Krikalev has aged 22.68 milliseconds less than all of us here on Earth. Right now, he is the record holder for time travel. If you get very close to something extremely massive, you can travel forwards in time too. For example, take the ultra-massive and recently imaged M87 star black hole. This is it projected through time. Because extremely large masses can warp space-time in weird ways, your light cone will start to squish and tilt and tip over the closer you get to a black hole, and so time will pass more slowly for you as if you are going ultra-fast. And you can see right here at this exact distance from the black hole, your light cone tips over so much that your world line, the only possible path that it can take, is into the black hole, because otherwise you would be violating the light speed boundary. And as far as we know, humans cannot travel faster than the speed of light. Yeah, I know, I said humans can't travel. Anyway, this actually defines what is called the event horizon, and this is why scientists say at this point, not even light can escape. So the closer you get to a black hole, the less time passes for you relative to the rest of the universe, and you travel forwards through time. You look fantastic for like 70? Traveling to the future is fine and very possible, but it doesn't exactly help you address a certain snap, and going back to the past is a whole different endgame. I'm gonna say this right up front, okay? Most scientists who spend their lives thinking about this kind of thing think backwards time travel is probably impossible. There may be some weird hypothetical situations, there may be some weird hypothetical situations or some kind of weird exotic matter that might make these situations more possible, but these explanations themselves are extremely unlikely. All of that being said though, what if you could make a wormhole that traveled at the speed of light? Let's say that Tony Stark anticipated the Battle of New York in 2012. He used billions and billions of Stark bucks to somehow make a wormhole that connected two different points in space and time, and whatever technology was holding those wormholes open could also move them through space-time at incredible speed. Now let's say that he constructed the wormhole in 2008, right after he became Iron Man as some kind of insurance policy. He then spent the next few years accelerating one of these ends at near the speed of light. Because of the kind of forward time travel that we just talked about, when this end stopped accelerating, it would actually be younger than the rest of the universe. Maybe the rest of the universe is at 2019 now. The really weird thing about wormholes is that time is synchronous through them. So if Iron Man and the rest of the Avengers now entered the wormhole that had an age of 2012, they would emerge from the other end in the year 2012, right before the Battle of New York. Another suitably I was gonna say that, future me, shut up. Another suitably superhero-y way to theoretically travel into the past is to construct an infinity tube. It's kind of fitting. In 1974, scientist Frank Tipler proposed a solution to the general relativity equations that would allow for backwards time travel. He theorized a giant rotating tube in space that was infinitely long in each direction. The rotation of a tube like this is so incredibly taxing on the space-time around it that it would warp it in the same way that a black hole would. Light cones near it would start to tip over. Going back to our diagrams for a second, you can see that if our light cone tips over enough, the path your world line can take doesn't necessarily have to go forward in time. It can go backwards. If traveling through warped space-time like this can theoretically take you into the past, then there is a path along a Tipler cylinder with all these tipped over light cones where you could go around it and take yourself as far back into the past as you wanted, going around, past. Maybe you'd get far enough back to like get the one that got away. Peggy! Oh! They danced. Now though, there's a problem. If there is a way to curve a world line so much that it comes back around through time and intersects with itself, it forms what scientists call a closed time-like curve. It is time-like because it is still within the light speed boundary and events can be causally connected from A to B. Thanos gets the Infinity Gauntlet and then he snaps. The problem for the Avengers is that even if you curve this line to travel back in time, Thanos snapping is still on the world line. It happens sometime in the past and therefore it has to happen. Thanos is right in this regard. He is inevitable. This principle is known as the Novikov self-consistency principle, saying that whatever happens in this weirdness still has to agree with what happened at all other points on the world line. This gets around the dreaded grandfather paradox, which is good, but it's bad for the Avengers, because in this view of reality, if this is the way you are traveling through time, you cannot change the past, period. Come on, I just got him back! If Avengers Endgame didn't have a way around all of these physics, we'd have to conclude that the movie is fun, but kind of logically impossible. Thankfully, quantum mechanics comes to the rescue once again. Hey, so you didn't do it. Butt coward. Have you ever wondered if you could have done something differently in your past? What would the world be like if you took a different path through space-time? Well, one interpretation of quantum mechanics says that you did. You did both. You did all of them. Every time you interact with the universe as a quantum system, as you are at the smallest scales, you split the universe, each one unfolding with a different history. This is physicist Hugh Everett's many worlds interpretation of quantum mechanics, and it posits an infinitely branching tree of timelines every time quantum systems interact. You, as a quantum system, have an infinite number of potential world lines, but at our scale as a collection of particles, we only really observe one path that we're going down. But all of these paths have some version of you and your history traveling along it. Again, this is all very theoretical, but other scientists, like most notably David Deutsch, who Tony Stark name drops in Avengers Endgame, the Deutsch proposition, think that if you could travel back in time from your world line and go back to the past, because of quantum mechanics, you would necessarily have to split off and then travel down some alternate history. This gets around any potential paradoxes because you can mess with a past that isn't your own. You could even mess with yourself. You could punch yourself in the face or get the hammer back from yourself. Still worthy. Yes! This gets around time loops and paradoxes, but more importantly, if you were to somehow use quantum mechanics to jump back from your alternate timeline to what you perceived as your own original timeline, you would be in fact in a future of your own making where you could change events in your perceived past, even after punching yourself in the handsome face. So now I think we are finally ready to address Endgame. Oh! Right, sorry, it gets even more fundamental than this many worlds approach. As we went through in detail in our Is Ant-Man Secretly the Strongest Avenger episode, we experience our own time as advancing from one point in space-time to the next. Our world line, at least to us, is a single line. If we could figure out a way to travel backwards in time and we got there to an alternate timeline like the many worlds interpretation suggests, when we got back in time, we would still experience our own world line in this way, advancing from one point in time to the next. When you go to quantum mechanical scale though, this solid line reveals itself to be something very different. Literally every single possible path through space-time. This was one of legendary physicist Richard Feynman's many great insights, that a quantum particle takes literally every single possible path through space-time, and some of those paths are even, yes, going backwards in time. But when we look at it from our human macro scale, all we see is the single most likely world line. We see the grand rope of time. We do not see all the fibers that weave it together. So, in the quantum realm where the Avengers are supposed to go, the path between 2 points in space-time doesn't look like this anymore. It would look something like this. Between every 2 points in space-time, there are an infinite number of quantum paths that would take you between those 2 points. I've represented it here as circles with decreasing density, saying that traveling from one point in time to another like this, like time travel-wise, would be very unlikely, and the most likely line is the one that we experience through space-time, the straight line. And of course, there would be an infinite number of backwards paths through space-time for a quantum particle between 2 points in space-time as well. My point is that every single point in space and time is linked quantum mechanically. At our scale, you cannot see this infinitude of possible paths. The collection of particles that we only experience the most likely path for those collection of particles, a straight line through space-time. However, if you got down to the quantum scale, you would see everything. The key to all of this is that if you had Ant-Man's Go quantum powers and Tony Stark's intelligence, you might be able to pick any weird, unlikely world line that you wanted to take yourself to a very specific or many specific points in space-time. Say 1 out of 14,605? And I know this is all very, very confusing, and honestly, I haven't wrapped my head around all of this fully yet. I have spent, for this episode, 10 hours literally on a phone with a quantum physicist. But keep all this in mind, keep the analogies in mind, and now it is time to address what actually happened in Endgame. Okay, so here's how the Avengers Endgame timeline actually shapes up if they are truly following a quantum mechanical version of time travel. I needed a lot of space. So here is our grand rope of MCU history, a story starting canonically all the way back in the 1940s with Captain America, the first Avenger, and then progressing over 21 different films to the events of Endgame, where somewhere around 2023, the Avengers get time travel, they go back in time, they get the Infinity Stones, they come back, the Hulk snaps, and then Tony snaps, and then people are dusted and undusted, and then Captain America comes back as an old man and makes you cry. Yeah, this is too simple though for this film and for quantum mechanics. So now, let's see if we can unravel this rope to see what quantum fibers the Avengers took in terms of world lines to do what we see them do in the film. Okay, so using the infinitude of possible quantum paths, here's what the Avengers actually do. In 2017, when Infinity War is supposed to take place, there is a snap. There's a 5-year time jump, and then there is time travel. From that point, they use the powers of the quantum to take these unlikely world lines back to 2012, 2013, and 2014. From there, they each have their separate missions to grab the different stones, eventually all returning back to this point, while Cap and Tony travel back to the 1970s to grab the Tesseract after it falls out of their hands and into Loki's hands. Oh, I wonder what happened with him, we don't know. And then they also grab more Pym particles. They also jump back to the same amount of time. A brief amount of time later, Thanos, an alternate version of Thanos and an alternate version of Gamora and Nebula both jump back to this original world line. From there on, Hulk snaps, and then Tony snaps, and the movie is more or less over until Captain America returns all the stones. First to 2014, and this is just my interpretation because it would look pretty and make more sense. First to 2014, then jumping back to 2013, 2012, 1970 to return the Tesseract, and then to the 1940s to take an unlikely alternate world line with the power of the quantum to live out a full life with Peggy where things may or may not have happened in the MCU, we're not really sure, and then he returns as old Captain America. This is a lot, so you might want to pause the video to get a handle on it. And remember, these are only the various paths the Avengers chose to take using the power of the quantum. In reality, there are literally an infinite number of paths to and from each point on this grand rope of MCU history, from 2012 to 2023, for example, and from 1940 to 1940 plus 5 seconds and back again. And remember, this is just my quantum mechanical interpretation of what's going on. The timeline of events in some Marvel production office might look very different. However, this approach does theoretically get around all of the closed time-like curve and potential paradox problems. I applaud the movie for bringing in quantum mechanics and acknowledging the problem with closed time-like curves. If this was just a single timeline, for example, there would be a lot of problems, like future Nebula shooting herself from the past. That would be Back to the Future stuff, and you know what the Hulk thinks about that. Quantum mechanics is really the only way that this works, because if you could get to the smallest scales of the universe, where an infinite number of branching paths through every point in space-time were open to you, you could, metaphorically, choose your own adventure. You could pick the one out of 14,605 world lines and live it as your own history and change your future. And from our perspective, our non-quantum perspective, observing all of this happen, it would all be the same story, the same endgame. So there you have it. 10 years of the MCU culminates in a surprising way with the quantum physics of time travel of all things. And much of the movie works theoretically if you give it the biggest possible benefit of the doubt, which I think we can do. There's inherent tension in any sci-fi story, and especially in time travel stories, between the narrative that you're trying to tell and the science that you're trying to get right. And sometimes one features more than the other, and that's fine. Endgame was very satisfying for me, and in all seriousness, the MCU has been helping me learn and teach and excite for my entire career. So thank you, Marvel. Your movie was pretty dang cool. So here's to another 10 years of and because science. I wonder if there's any footage I could show of any kind of science show that maybe, I don't know, a year ago predicted the exact mechanism of how Avengers Endgame would happen with the exact right characters. Could we find any footage like that? This is potentially a way to save half of the universe. Validated! You live life in the past. It's weird, I know, but even right now... Wrong timeline. Thank you so much for watching, Jonathan, and a big thank you to Dr. Spiros Michalakis at the Institute for Quantum Information and Matter, a good friend of mine who actually advised on films like Ant-Man and Spider-Man and Captain Marvel. He talked with me for hours about how to make this kind of time travel work, so thank you so much, my friend. I hope I didn't bother you too much. Also, we have the full series of The Science of Mortal Kombat now live. Please go watch all 6 main episodes. We worked really hard on them, and I'm glad that many of you are enjoying them. I very much hope to do something like that again for you all very soon. If you want to follow us on social media, you can do so right here to give us ideas for future episodes, and thanks.